In this lesson, we'll put all the pieces together and finally enable the user to filter our employees by entering a name into our input. Now, the good news is all of our employee data now lives in the component state. So it lives in a regular JavaScript array. And the good news is it's super easy to filter a JavaScript array. We can use a filter method on the JavaScript to select for employees whose names match the term that the user has typed in. We have our employees array in state, and we also have our search term in state as well. So we don't even need to worry about the UI per se. We just need to combine our logic correctly together in order to get the UI to adapt to our JavaScript logic. So when we think about it, our filtered employees that we want to show is an example of derived state. It is an alternative view of our original state. It is a subset of this collection of data right here. So whenever you have derived data, it's typically a good idea to not add that derived data to your state. So what I'm saying is we don't want to have another property on our state called filtered employees, because the problem with that is we are duplicating data. And for example, if one of the employees' initials changes, or maybe their job title changes, we have to edit that information in two places now. That data is duplicated. So whenever you have derived data, or in other words, data that is dependent on some other data and changes alongside with it, what you want to do is put that logic in the render method, because the render method will rerun each time state changes, and then that derived logic will also rerun in the render method if we put it there. So here's what we're going to do. If I scroll down, we have our complete employees state right here. This is an array of 5 objects. I want to narrow down that array of 5 objects to an array of however many objects match the user's search term, right? And here's what we're going to do to make that happen. We already have the search term in our state, and we've destructured it. The first thing I'm going to do is just to normalize it. What that basically means is just in case the user gives me a name in some kind of weird casing, like capital letters all over or all lowercase, I basically want to make sure we're starting with a comparison that is really easy to make. So what I'm going to do is take their entry and lowercase all of it, and then I'm going to compare that lowercase entry to a lowercase version of all of my names. So the first thing I'm going to do is declare a constant called normalized search term. And all that's going to be is taking my search term property from state, which again is coming from the user's entry in my input. And on that string, I'm going to call JavaScript's built-in toLowercase method. So now, for example, again, if the user gives me a string like Michael, I'm now going to have Michael. And then I can compare that lowercase string with a lowercase version of all of the names in my employees array, and thus ensure that we don't have any problems in case the casing doesn't match what the characters do. All right, so the next thing we need to do is take our employees array and filter it. We can do that in JavaScript on an array by calling the filter method. As a reminder, this method accepts a function as an argument, and it represents a single iteration over each employee one at a time. So here I'm just going to provide employee as my first parameter. And what this should return is either a true or a false, a Boolean. If it's a true, then that element in the original array will be kept in the new filtered array. And if it's a false, then the current element will be discarded. So what we want to do is we want to return true wherever our search term is within the current employee's name. And we're going to iterate over every single one of the employees in our array, right? So the way this code is going to work is going to look like this. We're going to take the current employee that we're iterating over. That is an object, right? Because we're iterating over one of these things each time. On that object, we're going to have a name property. That's going to get us the employee name. Then I'm going to call toLowercase on that string. So now we have the employee's name in lowercase, and we're ready to make the comparison. One simple way to do this in JavaScript is to use the includes method on a string. And since the toLowercase method is returning a lowercase string, that string is going to have an includes method on it. Just like the name suggests, what the includes method is going to do is return true or false if the substring that you pass as an argument is found in the original string. So what we pass in here as an argument is what we're looking for in the string that the method is invoked upon. The string that the method is invoked upon is the full employee name. So what we want to search for within that full employee name is our normalized search term. So save that and let Prettier do its job. And this is what our code is going to look like. We're going to iterate over our complete original employees array of 5 employees. For every single employee, we're going to take their name, lowercase it, and check if that fully lowercase name includes the user's current search term. And that is going to give us a new array. That array may have 3 employees, or 2, or 1, or 0, or maybe all 5 if the user has entered a character that happens to be found in all of those employees' names. So what I'm going to do is assign this to a new constant called filtered employees. So now this is our derived data. This is our newly generated array that is based off our original employees array from state. So we are not duplicating data, rather we are deriving this new array in our render method. We're not saving it to state, but every single time the component re-renders, we're going to run this logic and make sure we have the most up-to-date filtered employees array. The only thing that remains is altering our code down below, where right here, we no longer want to render a card for every single employee. Instead, what we want to do is render a card for every filtered employee. All right, so right here, I'm going to change this to be filtered employees. That is our constant that we defined up here, which is our derived array, and save that. Now here's the cool part about this. When the page loads, you'll notice that all 5 of the cards are going to show up. And the reason for this is because our search term right now is an empty string. So our search term looks like this. And the cool part about an empty string is whenever you take any JavaScript string, like let's say the string Michael Scott, or even the string Michael Scott lowercased when we do so, whenever we take a string like Michael Scott and we call the includes method on it and we pass in an empty string, that will always return true. So no matter what our original name is, if we invoke the includes method on that and pass an empty string, we're always getting true. So when this component first renders and this method runs, this filtered employees array is going to return true for every single one of those iterations. So our filtered employees array ends up looking the exact same as our original employees array. And that's absolutely perfect on render because we're going to see all of our original employees pop up on screen. Then when the user enters a character, that is going to trigger a change to state that's going to update the search term piece of state, which in turn will force a rerunning of the render method. So now the logic will rerun, but the second time around, the search term and then the normalized search term will be updated. It will have the one character that the user enters. And so once again, JavaScript will filter our original array of 5 employees to those whose name includes that one character, and that array will likely be shorter, and that's what we're going to re-render, and thus the employee cards are going to disappear if they're no longer valid. In other words, if the user's search term is not found within the name. So let's see how this is going to work. So, for example, if we enter the letter M, you'll notice that we go down to 3 cards. That's because there's an M in Michael Scott, there is an M in Jim Halpert, and there is an M in Pam Beasley. Once again, the beautiful part about our design is it's case insensitive. So if I type in a lowercase m, it's not a problem. We're going to get the same result because we are normalizing our search term right here. That was our intent, to make sure that we don't run into any kind of problems in this includes comparison, is we're just comparing all lowercase to all lowercase, right? And as I type more, the search is going to get more in depth. So for example, if I type in I, now Michael Scott is the only string or the only employee name that includes the characters MI in that order. So now we have successfully filtered the employee list down to this card. Obviously, if we have 5 cards, this isn't super helpful, but you can imagine if your employee registry has 150 cards, this is super helpful to identify all the Michaels, right, in the company. So here's another example. If I search by last name, let's say I want to search for H. Now we have identified all the employees that have an H in their name. If I instead say HA, now I can see that I have Michael and Jim Halpert. The Michael has HA, and the last name in Jim Halpert, HA, has a HA. So if I'm searching by last name and I'm looking for a Halpert, I can enter Hal, and now that is enough to identify that employee card. All right, and you can see as I type every character, we are updating the components on screen, and that is because with every character type, I am triggering an event which is updating the search term piece of state, which is triggering a re-render and thus generating a new filtered employees array. And that is what we're iterating over here and generating a new card for. And that's the beautiful part about this design is if we have a filtered employees array of 5 cards or 3 cards or 0 cards, React will figure out how to render that number on the screen. And we can focus on the actual JavaScript logic up above without having to worry about the corresponding UI. The UI will automatically be taken care of by React. We just simply have to give it the right array to iterate over to generate the right number of cards, right? So this approach moves more of the logic into React, more into JavaScript, compared to manually hard-coding all of that data like we saw a couple lessons ago. It would be a lot harder to filter 5 cards down to 2 if we obviously hard-coded all of them directly in line. But now we are mixing and matching JavaScript logic with our JSX rendering, and that is kind of the beautiful part of React, that we can use methods like map, that we can use methods like filter to decide and conditionally render our UI, right? That's kind of the beautiful part about React. So this is our first working prototype of our employee registry, but as I mentioned, all of our data for the employees is currently hard-coded. So what we're going to move on to in the very next section is getting this data from a mock backend. So our component will load, it will make a request to get some data, and then it's going to populate that employees array with the data that it receives from our backend. And we're going to learn a lot about various parts of the React ecosystem throughout that process. So I hope you enjoyed this section. I hope you had fun, and I will see you in the next lesson.